Namaste everyone, welcome to the class. Now in this lecture we will see a new chapter called circle. So our topic is circle. Now what we mean by circle? Circle, it is a set of point or a group of point which is at a fixed distance from a fixed point. So this is a fixed point. Now from this fixed point I have group of point at a fixed distance. So suppose this distance is a fixed distance. Now at the same distance I will draw different points and join them. So the shape which I will get is a circle. So circle is a group of point which is at a fixed distance from a fixed point. Now that fixed point is called center of the circle. Fixed point is center and the fixed distance is called radius of the circle. We can also define radius of the circle as the segment joining the center of circle and any point on the circle. Now this length of circle is called circumference of the circle. Circumference. So circumference is what? Circumference is this outer length. Okay. So if I take a point A on the circle and cut it here and I will stretch, then the total length of the circular boundary which I will get is the circumference of circle. In case of rectangle or any other figure, we call this length as perimeter. So sometimes we can use the word perimeter of circle also. So perimeter or circumference of circle, both are having the same meaning. Now this fixed distance radius, generally we denote this with a letter r, a small r, that stands for radius. The circumference of circle is related to the radius. As we increase radius, the circumference will also increases. And there is a formula by which we can calculate this total length, which is 2 pi r. Now here this pi, it stands for a value 22 divided by 7. Now this 22 divided by 7 is the approximate value of pi. Pi is an irrational number. Its value is 3.14 ... So the value is irrational, but its approximate value which we can take is 22 upon 7. So whenever in your problem radius is a multiple of 7 or there is anything which come in multiple of 7, there value of pi 22 upon 7 is useful. In other cases, we can take the value of pi as 3.14. Moreover, when you solve the problem, in problem itself they mention what value of pi you have to take. Now this circle divides this whole plane region in three parts. This circle is a planar diagram, we can say. It has two dimensions. So in plane we can draw a circle, a planar figure we can say. So this circle divides this whole plane in three parts. One is inside of the circle, other is circle itself, and third is outside of the circle. Now this inside of the circle is called interior part, circle is called circle, and outside part is called exterior part of the circle. This circle and this interior part, they together form circular region. So circular region is what? Circular region is circle and its interior part, that is called circular region. Now if we take 2 points on the circle and join them, then we get a segment. That segment is called chord of the circle. We can draw a chord which can pass through center of the circle. Now that chord will be the longest chord for a given circle, and this longest chord of the circle is called diameter of the circle. So diameter is longest chord of circle. It is passing through the center. So from center to point C it is radius, from center to point D it is radius. So this diameter is equal to 2 times radius. So diameter we indicate with small d. So d is equals to 2 times radius, and this diameter is longest chord of the circle. Now if I take 2 points on the circle, and if I cut at these 2 points, I will get 2 parts of circle. One part something like this, AB, and other part is something like this. This also we call as AB only. Okay, so this smaller part is called minor arc. So each part is called arc of the circle. So circle can be divided in different arcs. Here I have shown you 2 arcs. Okay, in the same way you can divide in 3 arc, 4 arc. So we divide circle in different arcs. Now arc which is smaller in length is your minor arc, and this which is larger in length is called major arc. I will say arc AB. So when I use word arc AB, it means I am talking about minor arc. So if we are not using word minor, then by default its meaning is minor. We can say arc AB, or we can write this as AB, and on top of that we can show the symbol of arc. I prefer to write arc AB. Similarly, this bigger portion is called major arc. So major arc AB means I am talking about this bigger portion, and in symbolic form we can write that as A. We will take one more point on this major arc, say C. So I will say that ACB. So major arc is represented by 3 symbols, minor arc is represented by 2 symbols. Now here the ends of the symbol are the end points of the arc. Now let us take again 2 points on circle, say point A and B, and join these 2 points. If I join these 2 points, what I get chord AB. Now the area of the circular region between this chord AB and this arc AB is called segment. Okay, so what is segment? In short we write SEG. Full form is segment of circle. So when I join endpoints of the chord, when I take the area between chord and arc, I get segment. So segment is the area between chord and arc. Now again I have 2 type of segment. One is minor segment and one is major segment. So minor and major. So when, or I will say that the smaller part is called minor segment and bigger part is called major segment. If the endpoints of chord are the endpoints of diameter, okay, then in that case minor segment and major segment both are equal, and in that case it is called semicircular region. So this is semicircular. So what is semicircular region? Semicircular region is the circular region when the endpoints of chord are the endpoints of diameter. This is semicircular region. There is one more way I can define area of circular region, that is, I will take again 2 points, say P and Q. Now this time I will join this endpoint P and Q with the center of the circle. So when I join them with the center of circle, I will get area like this. In this case, this is called area of sector. So here we call this as area of sector. Now when defining area of sector, I will first write center O, and then I will mention these endpoints. So I will say that area of sector O, then I will use a small dash and write PQ. So area of sector OPQ. For the major sector, now this is minor sector and area of major sector, I will write O, then I will take one more point on this major part, say S, and I will say that O PSQ. So this is minor sector, area of minor sector, and this is area of major sector. Again here, if this point P and Q are the endpoints of diameter, then your minor sector and major sector both are equal, and that is called semicircular region. So semicircular region, okay, we can find it from area of segment as well as area of sector. So these are few basic things that we will see before we see our first exercise. So what different things we have seen here? We have seen the definition of circle, we have understood what is radius, what is chord, what is arc of circle, what is segment, area of segment, what is area of sector, what is semicircular region, what is circumference of the circle. Yes, okay. So now with this information we can solve our first exercise. So exercise 10.1. So let us see that exercise 10.1. Now here the center of circle lies in, now we have to fill in the blank. So simple exercise, the center of circle lies in dash of the circle. So what will be your answer? Exterior or interior? So center is where? It is, yes, you are right, it is in the interior of the circle. So interior is your correct answer, interior. Second question, a point whose distance from the center of circle is greater than its radius lies in, so a point whose distance from the center of circle is greater than its radius. Now if the distance, you can see this is a circle, okay, a point whose distance from the center, this is center, now from here to here it is radius, and if the distance is more than radius, so point will be somewhere here. So tell me where this point is. The point whose distance from the center of circle is greater than its radius lies in dash. Where it lies? It lies in the exterior of the circle. The longest chord of circle is, now the longest chord, what we call longest chord of the circle? We call this as diameter. An arc is a dash when its ends are the ends of diameter. Now when ends are ends of diameter, what we call that as? We call that as semicircle. Semicircle, okay. Now the segment of circle is the region between an arc and chord of the circle, okay, right? And a circle divides the plane on which it lies into how many parts? It divides it in 3 parts, right? Okay, now the second question is true false type question. We have to give reason also. Line segment joining the center to any point on the circle is radius of the circle. So this statement is true. Yes. A circle has only finite number of equal chords. A circle has only finite number of equal chords. No, this is false. If I start drawing the chord, I can draw infinite number of chords as there are infinite number of points on the circle. Okay, like this, like this, like this. So a circle has only finite number of equal chords. This is false statement. If a circle is divided into 3 equal arcs, each is major arc. Now let us see. If there is a circle and we divide it in 3 parts, and 3 parts they are of equal values. So as I am getting a major arc or a minor arc. Now major arc means it should be more than semicircle. So here it is not possible. They cannot be more than semicircle when it is 3 parts. So a circle divided into 3 equal arcs, each is a major arc, is a false statement. Because I will say, because each arc will be less than semicircle. Fourth, a chord of circle which is twice as long as its radius is the diameter of the circle, right? This is true statement. So we can say that when it is twice the radius, it will be the longest chord and hence it is a diameter. Sector is the region between the chord and the corresponding arc. So this is false statement. Sector is the region between the end points of arc, or I will say that the sector is the region between arc and the line joining endpoints of arc with center of the circle. And last question, a circle is plane figure. So this is right. A circle is plane figure. Plane figure means it lies in a 2-dimensional plane. Yes, circle is a plane figure. This is true statement. I hope this exercise is clear to you all. I will see you in our next class. Thank you. Thank you for being with me in this class. Thank you once again.